Ես էլ ես այդտեղ կողա ինչ են հասկանում։
Okay. Այսօր եկեք ընկերի ունենալու, առաջինը խոսելու հենան asynchronous trilogy երկրորդ մասն ունենալու, երկրորդ խոսելու նշան խոսելու performance issue-ներ գտնելու մասին PGProfile-ով, ու մեծ շնորհակալություն դատարակին, ովքեր որ մեզ հովանավորել են նախանախորդ վիդեոցառումը այս ու հաջորդ վիդեոցառումն հովանավորելու, ու մեսի դες, որ եկել եք այսօր, հիմա ես ներժի կգնարվեմ նաև բանքները, բայց մի կարճ տարբերակով. So welcome everyone, we are starting the 18th PYerevan. We're going to have two talks today. First one will be the second part of Asynchronous Trilogy by Henry. The second part will be Misha talking about performance issues and how to handle them with PGProfile. We're going to be like in between languages. It will be Armenian English and Russian, so just tune yourself to switching languages pretty frequently today. And the big thanks goes to .art for sponsoring our events, 3 events in a row. And take it away. Thank you.
Yeah, thanks. Thanks for the intro. So, how many people here do not speak Armenian? You do. Quite a lot. How many people do not speak English? So that's an obvious choice. We'll move on with English. So since some people are late, and we'll start with a couple of jokes, with some intro, with some recap from the previous presentation. So before we switch to current one, I hope some other people will join as well. So how many people were present during my last talk? Yeah, it was a bad one. Thanks God, not too many people here. But actually last time we were speaking about, we were getting some base info about what parallelism is, what concurrency is, and why the hell will we need async after all. So we came to a point that we understood that async is somewhat necessary sometimes. So today we are going to continue from that point, and we're going to understand how async is done in Python. So here's a brief outline of the 3 talks we were planning. So we already did the first one, now we are on the second, and we still have one more, which will be about the practical application. So today we'll see how to do async in Python, but we will not touch many practical examples, only a few brief ones. But the next time we'll try to also cover the part where we'll try to use our knowledge for creating some kind of, maybe some web application, maybe something else. I don't want to spoil, and I don't know it myself either. So this is the second presentation in the series, and today we're going to speak, as I said, we're going to have some recap. Then we'll speak about coroutines and generators. So if you remember last time, I advised you to have a look at generators to refresh your knowledge, because it will help us today somehow. Then we will try to understand how stacks work in an application. So you have a code block. How is it working? And we'll try to see how event loop is different from the ordinary stack memory. Then we'll speak about awaitables, a bit about futures and tasks, and we'll briefly see how to execute async code in Python. Just briefly, because that's the main topic for the next presentation. So let's start with a recap. So we had two main terms. We had the concurrency and we had the parallelism. So basically, let's say we are in the kitchen and we are making some chia pudding and avocado smash. So we have 2 options. Either 2 people are working like separately in parallel. They are doing the work at the same time. One is making pudding, the other is making the smash. So 2 people working in parallel. The other one was concurrency, which is like one person working. I'm mixing the chia, then I'm smashing the avocado, then I'm coming back to the pudding, and then so if there is a time to wait for something to hit, maybe I can do something else, so I'm not also losing resources. Another interesting thing we touched during the last lesson was the threading. Threading is usually considered to be a parallelism concept, but actually in Python we have an issue. We have the very famous GIL, Global Interpreter Lock. How many people are not familiar with GIL after all of this? 1, 2. So I briefly touched the topic during my last talk. Also, there is a talk by Vlad, if I'm not mistaken, during one of the PYerevan, which you can also have a look at the recordings. And there are actually a lot of videos about that. That's an interesting topic about the implementation of Python. So some limitations. To recall, the GIL is about the race condition in reference counting. So for some reason, when we have 2 threads working, we have some issues with reference count. It's decremented not correctly. So because of that, we might have a memory leak. So instead of putting some different complicated logs, people at Python decided to put one log, which is GIL. So even though we have multi-threading library, it's not 2 things being done at the same time. So we also understood that the reason we still have threading in Python is there is some kind of concurrency. To be more exact, so we discussed that we have preemptive and cooperative multitasking. So threading is an example of preemptive multitasking in Python. What that is that we have different threads and we have some kind of supervisor. So it may be an operating system, it may be some other process, which in its turn is deciding when to stop one thread and to switch to the other. So let's say we have the first thread that comes to a point that makes a request to the database and it is stale for a while. So someone instead of us will decide that at this point it may interrupt that thread and pass to another one. In a sense, it's similar to async, but it has a huge problem which we are going to try to solve today. So the problem is that since we do not have control and we do not know when the threads will be switching, when what will be executed, it's very hard to use. It's very hard to use to do memory sharing with that model. So let's say we have some kind of list, and so the simplest example will be to print it. So let's say one thread decides to stop at a point, and so also it's not how they call it idempotent. So if you run it multiple times, you might get different results. So the list will be changed in an unexpected ways. So that's the main problem we are trying to solve today. So before getting back to our main topic and starting with async, if you have any questions now, or maybe if you will have any questions during the presentation, feel free to scream and shout and give it at that exact moment, and we'll have some QA session in the end. So let's see what we can do. Let's see how we can fix the issue with threads. So first, let's speak about subroutines and coroutines. So we may try to do, I think I have a code example already here, so I don't have to live code now. Let's say we have this ordinary function. You probably wrote this kind of functions many times. So what this particular one does, it takes just a number, it does some checks, and it returns the factorial. So if the number is less than 0, it's defined 0. If it's 0 or 1, the definition is that the factorial is 1. In the other cases, it uses some for loop to iterate n times and find the factorial of that number. And we have the call here. So in this case, what happens? The interpreter passes through this code, it gets to this point, it calls this particular function, and then what happens? This function has to be executed from the beginning to the end. So the whole, nothing else can happen before this particular function is done. You get it, right? So starting from this point up to this point, nothing else can happen. So this is like blocking our application. Maybe there's a meaning for blocking, like in this case, the CPU is always counting something. In some other cases, there may be some stale situations when you have to wait for something. So to get to cooperative multitasking, we need some kind of concept, we need some kind of mechanism to implement ability to stop at a point, to stop the execution of the function at at one point, switch back or switch to the other one, and then the ability to come back later. So if you are not familiar with async, maybe you are familiar with the generators. How many people are actually familiar with the generators and use it in practice? Yeah, quite a few. So yeah, basically what generators do, they start execution, they reach to a point when we have the yield statement. At that point, they return the value. And then after the next call, they can come back and continue the execution. So what we have here is, again, we have this, our basic factorial function, but instead of returns, we have yields here. Actually, those two can be returned as well, but it doesn't matter. So what will happen here, the program will get to this point. It will call the function factorial. It will get it will start working. It will get to a point somewhere here, and it will yield the first value. Then what will happen, the program will come back to the line 14, or should be, line number 13. Then on the next call, so as we have a for loop here, it's calling the function again, so it will iterate again, and function will be called again. So what we have here, we have the ability to switch back and forth between the different parts of the program. Now we don't have to wait before the function is executed from the beginning till the end. We can call it, get to some point, get some value, continue doing something, and again get back to this function. So this is pretty useful. It's also useful in many cases. For instance, I usually bring the example of reading a big file. So let's say you have a file that is 5 gigabytes and your memory is 4 gigabytes. You can't read it entirely, so you can use, for instance, some kind of get generator to read chunk by chunk, and then read, pass to your program, do something, and get back. So the generator, they were in Python even before the whole async was implemented, and those were the first examples of coroutines. So what we have here, again, we have ability to switch back and forth between different parts of the program. So we can we can get to point, yield the control to another part of the application, and then they also implemented three very interesting methods for generators: the send, the throw, and I don't remember the third one. So send is enough. So at some point, they also implemented the ability to send back values to the generator. So after that, it's not a one-way process, so it's both ways. So you can yield control to other part of the application, then the other part can send you back values, which you can again process, get some other values, and again switch back and forth, sending values between like two parts. This was very interesting, and this was like the base for later development and for later implementing the async in Python later. Do you have any questions, by the way, about this one? Yeah? No? Hey, Ruben. We were waiting for you, but you were like a bit too late. So.
You're waiting for me?
Yeah. For the first time, it's not you waiting for me. So let's have a quick refresher on the stacks and frames. I'll be very brief here because personally I don't even know a lot of implementation details about this part, and it's very low level. Most of you probably never did or never even will touch this part of programming. So you always hear those two common terms, the stacks and heaps, and you never know what it's about. It's how actually the program is stored in the memory, how it's executed, and so on, and back and forth. I think we can try some kind of example here. Actually, I will try to code a very small Python code block, and then we'll see how it works. So since I don't have a holder, I need to put this down for a second and start coding. So it's simple. I don't have to do a lot of the description, so I'll just write and then we can briefly discuss and move forward. Okay. So I hope it's not that Pythonic, but never mind. So we have couple of basic functions here. We have the foo, which is returning the square of the given number, and we have bar, which has a value, and then it gets a new value by calling the foo function, and then we are calling the bar. So now let's try to understand how this works in our how our computer interprets this, how it executes this. So you are probably familiar with the concept of stacks from maybe data structures course, from maybe something else. And you might also have heard about the term last in, first out. So this is what Python actually does. In this case, let's try to draw it. It should look something like this. Yeah, this one is good. So we have this start of the stack. Then our program, for every function call, here our program will create a new frame. So program starts execution here. So our first frame will be for the bar. So what we will have is something like this. We will have this frame for bar function, and then it will put on top of it all the variables we have here. So we have val, which is equal to 12, and actually let's change something here. Let's use. So we have val, which is equal to 12, and the next step, the next level in this tag is the return point at the line 7. Now, for the further execution, our program needs to execute the other function, which is foo in our case. So what will it do? It will create another frame for function foo. And again, we have x, which is equal to 12, and we have a return point at line number 2. This actually, I think we need to switch those, but not very important for our context. So what happens now? Our program executes the line number 2, which is in particular the statement x squared, and now it has to come back somehow. So what will happen after the execution? This part will simply get deleted, and now we have to have we will have the new val here, which is equal to 12 squared. It's 144. So I'm drawing this to give you an idea that there is a limitation here. The limitation is that with this approach, our program has to start at some point and has to sequentially execute all the statements. And again, we are missing the ability to switch back and forward between different parts of the program, right? Even if we implement generators here, again, in that case as well, we will have like this, let's call it linear stack, and it will, again, one by one execute step by step all the processes one after the other. So we need to have some kind of solution here, which in our case is very famous. I don't have the slide. Here we can bring the concept of event loops here. So you've probably heard about event loops many times. So let's try to briefly understand what an event loop is. It's not that complex. It is complex, but it's not that difficult to understand. So basically, what an event loop is doing, instead of having one stack, the application is divided into tasks, and tasks are in the event loop, and each task has its tag. Yeah, event loops are funny, yeah, I know, especially in JavaScript. Now for each of the tasks we have a separate stack. And now we have the event loop has the ability to switch back and forward between different tasks, and so we can stop at one point here where we'll need to wait for something, and then we can switch to another task and do something else. So we are coming to the case when I'm cooking something and I don't have to stand near the stove and wait before it's hot, but I can go do something else because event loop, which is me in this case, has the ability to switch between the tasks. So maybe we can try to draw something again. Let's keep it simple. In the middle we have this event loop. And we have separate tasks. First task, second task, and the third task. And event loop has the ability to switch between those tasks. Each of those has its own stack. It should be something like this, and they can work and that. So now we have the ability to stop at one point, switch to something else, and then come back later. Okay, so we understood two important things that will help us with the async. First is that instead of subroutines, we can have coroutines, which are ability to switch back and forth between the programs in terms of code. So our function can be written in a way that at some point we can hint that we can stop here, get back to the other part, and come back and then execute the other code block later. And we have event loop, in which case we can have separate tags for each of the tasks. And also, again, we have the ability to switch between those and not limit ourselves, not limit our memory, and so on. So based on these two concepts, some people at one point in Python 3.5, 6, no, maybe even earlier, they've implemented the async coroutines. So basically what an async coroutine is, it's some kind of function that can be written in a way that we can tell it to stop at one point. The control can be yield to the other part, and then we can come back and execute that later. You'll get the idea in a second. Actually, to implement an async coroutine in Python, so when we are defining the ordinary functions, we just write def, the name of the function, some parameters, and then whatever. For the async functions, we just write async def, so and then the name of the function, again parameters, and so on and so on. a couple of definitions here. Actually, we can consider async def to be a separate statement. So def is a statement by itself, but async can't be used separately. So you need to have async def. There are also two other cases, async for and async for and async with. So we also have asynchronous generators and asynchronous context managers. We will not touch that topic at this presentation. We'll see if we'll need it next time because for the application, but it's also something interesting. You can have a look later. It helps in a lot of different situations. So basically that's it. So this is not that different from the ordinary function. You can actually do almost everything here. You can write the synchronous code, but the opposite is not true. So you can't write a synchronous code in async code in normal function, but you can write sync code in async function. Actually, let's try an example here. Not very scalable, but it will work. So I am scalable. So let's say we are defining a simple Python function. Let's call it foo again. It has a parameter x, and I have no idea what's going on there. You all probably can guess what the output will be, right? So let's try to run this, and we'll get some kind of a number, which is...
Henrik, please try to respond in upper half of the display.
And the output is not visible either, so... So basically, in this case, we have a simple function foo, which takes a number. Again, it returns the square of that number. And when we call that number and save it to a variable r, it's saved to that variable. And when we try to print it, it's printed on the screen. We have this magic number, 1,764, whatever. Now let's try to create. Let's try to do the same, but with async def. So I already mentioned that you can write the same code, same synchronous code in async functions. And let's try to do the same. We have almost identical code, except for now, instead of defining the function normal way, we are defining it the async function. Let's try to execute this and see what will happen. Oops, not bar, but B. So now we can notice that when we are calling async functions, we are not actually getting the result, but we are getting something that is an object. It's an instance of a coroutine. So it's a coroutine object. So when we are defining the functions and we are async functions and we are calling them the ordinary way, they will not execute and you will not get the result yet. So instead, you will get some kind of coroutine object, which we need to execute somehow. But wait, so since we have a function and we also need, we have a function and then thus we also will need a way to, yeah, I might just. Since we have a function, we also need a way to call that function. And also we have seen that async functions are not returning the value, but are returning awaitables. So what are awaitables? Maybe we don't need this anymore. So there are three types of awaitables in Python. First is coroutines we have seen. So basically it's something that can be executed separately, so we are passing control to other part. There are two different approaches to which we will come back in a second. So first awaitable in Python is the coroutine object we have just created. So it's awaitable. We need some way to execute it. The other one is all of the objects that are subclass of async IO future class, subclass or nistos. And the other set of awaitables are all the objects you create with specifying await the other method. About the latest, you can create a whole set of endless, unlimited set of new awaitables, so you can use this, but probably you will use it only in cases when you're creating some kind of library and you have to have some complex data structure, something. Maybe you might need it in a case when you are trying to implement the existing library, to port the existing library to async version. So you have a library which is sync. Now you want the async, you can implement the await, and it will help. Those are basically the three types of asyncs. So as I said, we need awaitables. So also we have this await keyword in Python. This is probably one of the most important things. This is the basis for async. So we have this async, and we have await. So await can only be used. It can only be used in an async context, so in async code block. So if we come back to my previous code and we try to, where is my mouse? And we try to await, let's say, this awaitable here. So we'll get an error, await outside function. So await can only be used in async functions. So we will see how to execute this later, don't worry. At this point, actually, let's have a look at an example and see how we solved our initial problem. This example is actually from somewhere from the internet. I was too lazy to write a new one. So let's see what we have here. Let's say we have this is abstraction. We have some kind of function that fetches some values from, it does some IO operations and fetches some values. So maybe it reads from the disk, maybe it makes a request. It doesn't matter. Then we have two separate async functions. We have fetcher and we have the monitor. Most importantly, we have this vals list here, which is shared between those two async coroutines. So if you recall, our problem was that it was difficult to share the memory. Now let's see how this model helps us to fix that problem. So what fetcher does, it's basically an endless loop. So it calls the get some values from IO as awaitable with the wait. So in this case, it's passing the control to the other function, which is in turn making some requests, and when it's ready, it's coming back to this point and continuing from here. Then it loops through the fetched values and it appends it to the list. So we have in this async function we have a part which is of course async with the wait, and we have part that is synchronous. Please pay attention to this part. So when this function is executed, this part can only be run in a synchronous fashion manner. So the process should finish before anything else here can continue. So if you get to this point, it should loop through all the values until done, then only then can the other processes continue. For the monitor, again, we have an endless loop, which basically prints the length of values that were added, and it sleeps for 1 second.
May I ask a question?
Sure.
So on line 14, is that three vals and like individual val, or
Yeah, sorry, it should be well. It should be well. So what this program does, it gets some values, prints to console, and then gets another set of values, prints to console. And so here, since we are passing control here to another function, and then the rest of the code is synchronous. So as soon as we have the return value from this, all of the other code will be executed synchronously. So let's say this function is fetching 10 values per request. So in this case, it is guaranteed that when the monitor is working, we will always have 10 fresh values which will be printed. So if you remember the threading approach, in that case, we don't know. At some point here, maybe it will decide to interrupt and come back to this. So in one case, we might not have a value. In one case, we might have 5 already fetched. In one case, more than 10. So in this case, if this function is fetching the exactly 10 values, since this part is synchronous, it will be added to this list, and the output of monitor will always be that 10 new rows. So with this basic example, we can see that how to some extent we solve the problems with threading, which is the difficulty of memory sharing. So since in this case it's cooperative, we know when we are stopping, when we are not stopping, again, when we are yielding control. Since in these cases we know what's going on and we have the control of our program, our application, it's not very easy, but it's easy to also manage the memory. It's easy to organize that in a structured way and avoid problems that we might have with threading. We have a couple of spoilers here. So now you can see how we can execute async. Maybe I can zoom in. But here you can see how we can execute async functions. We'll do it in a second. So those are the coroutines. We also have futures. It's similar to coroutines, so it's also something that's executed that happens separately from the main application. The main difference here is that so in case of coroutines, when we are creating coroutine, we have it and we can execute it later. When we have a future, when we create a future, it's executed immediately, and later we can get the value, see if it's an error or something else. To create a future, you can do that's a wrong code. You can create a future. It's a complex. Actually, it's a bit complex. I forgot to put it here. But to be honest, believe me, you won't have to create futures in many cases. There are available ones which you can use, and you will only need to create some kind of future only, and if you're creating some library and something low level to work with the other parts of the async. Also maybe about the tasks, so we can also manually create the tasks, so it's a wrong code snippet here. This one is actually for creating the tasks, so you can also manually create a few tasks. Each of those will have its own stack, and you can again pass those to event loop, and it will switch back and forward without interfering with the existing variables, without messing up anything, and so on. And also one more interesting thing from this slide is this line, await async io.sleep1. This is some kind of, let's say, maybe workaround. In Russian they say kastil. This is something to yield control. So let's say you don't want to do anything here at this moment. So this function, this part is synchronous, so you don't have anything new to print. You don't need to execute this. You can put something like this to yield control to the other parts of the application. So like fetcher continues getting the values before getting back to monitor and printing the values. So this is some kind of workaround to yield control. It's actually very useful and used in many cases. We'll see it also on our next talk when we'll try to we will try to see practical applications. Ooh. Yeah, let's get back to our code and actually try to execute it. I'm not sure I'll be able to do it, but let's try at least. Yeah, I'll use this for one last time. So, yeah, it's working. So as I already said, we can use await only in async functions. So let's create a new async function here. Maybe we can delete this part. Let's quickly define this async function called main. And now we can print Now, since we have the ability to use await here, let's await this bar coroutine and print the result. Finally, again, we have the problem. We can't run this, we can't call this either because it's also awaitable. For running this, let's use async IO library and let's hope it works. Yes? Yes. So, thanks. This async IO library gives us ability to gives us some functions and methods ability to run async functions. Here also, as you've seen in the previous example, we can create tasks here. We can create futures and many other things. Unfortunately, I'm almost out of time and we can't touch this topic in depth today. But I hope next time, when trying to apply our knowledge in some practical way, we'll also manage to see how we can use the full power of async IO library. But basically, it has some functionality to run coroutines, to run async functions, async generators, context managers, and others. Let's have a brief Q&A session, but that's not an end. I have an announcement, a brief announcement after it. So, if someone has a question, have some questions.
Yeah. First of all, thank you very much. And could you please? Let me ask my first question. Could you please show previous slide? So maybe it will be the actual code, like real code in your IDE, in PyCharm. Yeah, so maybe it will be the topic for next talk. But for example, where here is event loop, like what command creates event loop and how that gathering happens. Because that was the always tricky part for me to understand.
Actually, after Python 3.7, you don't have to create the event loop because it's created automatically. Before 3.5 or 3.6, you have to create the event loop to not create but start the event loop manually. Now you don't have to do it. Async IO has a function called get event loop, if I'm not mistaken. And it had run until complete and some other functions that can help you to interact with the loop. I will show it next time. We will try to create tasks and assign those tasks to event loop, so we will see it.
Yeah, okay.
So in most of the cases, not all, but most of the cases, you don't have to worry about the event loop because it's created, it's there, it's working. So for now, let's assume it's there. For later, we'll try to play with it a bit.
Question? Okay.
create your own event loop in testing, and that's, I don't know, maybe workaround for that, if you can say something about this.
Actually, I need to know some details of what kind of testing framework you're using and things. So that's why I said in most of the cases, and let's... Actually, in unit tests, for instance, if you're using the, let's say, Fast API, it has a separate class for the unit test. So, like when creating unit tests, you subclass from the unit with the test case, right? So, for instance, Fast API has async test case class from which you can subclass, and it solves some of the problems, including the problems with event loop. But it's not enough because I had problems with that as well. So I tried using it, and in some cases you're always having this problem. So async is complicated. It's more complicated than sync, and you're going to have a lot of like weird issues, as the colleague is mentioning. And yeah, you know, I definitely know that there is some way in Fast API. Maybe there is something else. I have to have a look for more details. Yeah.
If you don't have questions, let's have a small break.
Actually, I have one announcement. So I usually finish my talk with some quote, if you were here last time or before that. This time it's a bit sad because actually in 2 days I'm leaving Armenia for a while, for a short while, and I'm moving to Amsterdam. And I also had to leave my company, DataArt. I want to say thanks to all of you. People who used to come to my talks, my friends, my students, my colleagues, and I want to say thanks to DataArt for all the wonderful years I had there, all the experience I gained there, and I want to say thanks to PYerevan for this magical event. Luckily, I was here probably since the very beginning, right? From the very first talk, I was present somewhere there. It's not forever, it's temporary. I'm going to come back, and I'll also speak during the next PYerevan, but it will be, let's not spoil. Maybe live, maybe not.
Let's say that you visit Amsterdam to understand things like better in Pythonic way, right?
Yeah, because you know.
Python.
Actually, yeah. So you know, the Python was created in Amsterdam because Guido was from there, and there is also this. Okay, I will show it later. I'm also already revealing some personal detail. So yeah, there is this quote from Zen of Python that says, "There is one and only one way to solve things, but that solution may."
If you are not a Dutch.
Yeah, but that solution may not be that obvious if you are not Dutch. So I'm trying to be Dutch and see that obvious solutions.
Okay.
Yeah,
thank you very much. Thank you very much, Andy. He works as a doctor. Mikhail today tell us about PGProfile. I don't know, what is the language of talk? Russian, English?
English.
English, cool. Okay, thank you again, and let's start.
Should I use this microphone? Or?
This one just for
okay.
camera.
Okay. Hello there. I'm Mike. I work at Best Doctor as head of platform. So my job is to think about problems which affects not end user but the platform itself. So when when our Postgres database. Do anyone use Postgres here for your projects? Oh, yeah. So our Postgres database started to behave like this. So yellow is Postgres response time. I cut it there, so it started to grow, and after that, the only one way to make Postgres work was to restart the service. So actually, it affected all our customers. It actually happened quite regularly, like twice a week. So business was pissed off because, you know, they wanted our service to work reliably, and we had this. So they said, Mike, now it's your problem. Go and fix it. And our team started to, find where the problem is, what causing it, because our main application is Django monolith. At that time, it was summer 2021, and it was like 100,000 lines of code. So debugging performance problems was not very easy, and we knew that it was some problem with our Postgres. And first thing that you do when you want to understand what's wrong with your Postgres is, of course, you just open your logs and try to, go through the logs and find the problem. So slow query log, I think everyone knows that you can turn this logging on in Postgres, and it will write slow queries in the file. It's quite easy to use. It's work out of box. You need to switch one parameter in Postgres config file. But it's not very accurate, because Postgres actually writes in this log only queries that are slower than the time that you pass him. So you might want to say, okay, log queries that are slower than, I don't know, 1 second, or I don't know, half a second, or something like that. So it's not all the queries. It's quite inaccurate, and it's quite slow. If you want to log everything, it will slow your server, and you cannot just write all the queries in this log and think that it will work for you. Okay, and it's not actually quite visual. Reading Postgres logs is not fun. So you can use some external tools like PGBudger. It's a graphic interface which can take this slow log as an input and create a fancy HTML file with graphs and all this stuff. But the problem is that PGBudger is only will visualize your existing log. It will not add anything there. So it's as detailed as your log, and in time when I was using it, it was quite buggy. So it could skip, I don't know, part of your log, and for some reason. So it didn't work either. We used some other tools, like, of course, Prometheus, Grafana, New Relic, but it actually didn't help much. So here we come to PGProfile. This is quite cool instrument. It is extension for Postgres, which it collects your queries, collects stats about your queries, and creates quite useful reports, which you can use to find problems on your with your queries. And yeah, actually, this tool helped me in 2 projects, in BestDoctor, in one other project, which I volunteered to help with database problems. So, long story short, okay, first I want to show you how this reports looks and what we have found in our queries. So, Django RM. Do you use Django ORM? Yeah, we all love Django ORM in a way. It's quite, you know, it's user-friendly. You can do something like this. You create query set. There is a cool select-related feature. Maybe someone know prefetch-related, but select-related, you want some more data, you take your query set, you add some more select-related, and in a minute, your Postgres starts to look like this. And now I'll show which this query set magic, how it looked in our code. So this is one of the queries that we found where this PGProfile thing. It looks like this. And it goes, and it goes. Oh. Sorry. And it goes, and some more, and even some more. And wait for it. Here we go. Yeah. Left auto join. All this fancy select related looks like this in your query when you are, you know, not accurate with them. So here we had 38 joined tables, which of course our Postgres actually didn't like us. And when we did explain analyze for this query, you know explain analyze? For those one who don't know what it is, it's quite a cool instrument inside Postgres. You can write explain analyze and then your query, and Postgres will explain how he will execute this query, what actual steps he will do. And this explain analyze looks like this. Yeah, it really made us cry because it created lots of temporary files because this query was so big it actually didn't, Postgres cannot maintain it inside memory, so it created temporary files. Temporary files are slow, and yeah, that was not fun. So that's one of the examples. And but okay, this one is actually quite simple because this query was not very slow. We actually hadn't find it inside a slow log because we logged only really slow queries. It was not that slow, but it was slow and it was executed quite often. So when you have, I don't know, 5 of these queries in parallel, Postgres will say goodbye and will look like this. Okay. So I wanted actually to show you a couple of these reports. Okay, so PGProfile report look like this. It is HTML. You can actually get these reports in CSV if you want, but I never used this because I know HTML with these HTML tables is quite fancy. I like it much more than CSV files for some reason. So I think the most useful part of this report is top SQL by execution time. It's it is the slowest query which are called the most often. So as simple as this. So you can click here and yeah, this is, I think this is something from Django admin, I would say. So you just click on the row that you are interested in, and you will see the query itself. And here are some cool stats. You can see, number of reads, number of writes, CPU time, rows affected, mean time, minimum, maximum, all this. So you can just, take the most. These two are actually vacuum, so it's not. This one. No. I think something. So this one is vacuum because it was executed only once, and it actually took quite a long time, so we can skip them. But something interesting like this. This one is mean execution time is half a second, which is quite quite big, and it was executed. This is daily report, so it was executed not once, not twice, 100 a day. So we can go and see some fancy stuff like this. Yeah. So you can just take these rows from this report, go to your Jira, create tickets, and bring some cool work for your colleagues. They will love you for this, definitely. So this is slow queries, but slow queries is not, again, you can catch slow queries via your slow log. It's not as effective because in slow log you actually can miss these queries that are not that slow but executed quite often, like this one, which was executed like 15,000 times. So we can, I think, take these three and optimize them and have quite boost to our performance for our customers. But the funny thing is this one. It's, again, daily report. And here is execution times are quite fast, except this one, but okay. This one, top SQL by executions. Here we have the most executed queries. This is the other project. This is not Best Doctor, actually. The other projects which I helped with Postgres performance. This one, yeah, 500,000, 400,000, and so on. These queries are actually very effective, yeah. Maximum 10 milliseconds and nothing, yeah. Before you know that this report was taken when the system was used by 60 concurrent users. 60 concurrent users, 500,000 queries. So there was not very effectively written front end, which actually bombarded backend with these small, small, fast queries, and these queries are actually could be cacheable because GeoCity, yeah, you can cache it once on the front end, and you know you don't need to do, I don't know, 10 queries in a second for one user. So that's the problems that you cannot find with Slowlock, or I'm not sure if there are other tools that can help you to find this kind of problems. And that's why I really love this PGProfile thing. It's really cool, and if you're using Postgres, I really recommend you to you know, spend I don't know, an hour and set up this extension. It's really cool. So okay. So this is what this section does. Again, it collects not just query logs, but execution statistics, CPU time, rows selected, and so on. It has minimal impact on Postgres performance, which is cool because, you know, Slowlock, if you turn it on and make it log every query, it will slow down your Postgres like crazy. It's easy to generate these reports. You can actually make them, you know, weekly by some cron job and send them to all your colleagues' emails, so they can, you know, look and see what they have done with your Postgres. How do you set up it? It's actually, it's not hard, but it will take some time. First of all, because I haven't found any Debian or RPM packages for this extension. So you will, first of all, you will have to create Debian or RPM package yourself. It's, again, it's not hard, but it will take some time. Then there is, again, documentation for PGProfile. It's big, but you have to read it very carefully because, you know, it's, I can say it's very user-friendly. And there are many things that you may, you know, may not mention when you first read this documentation. You can, you know, miss some valuable advices. And I think one of the most valuable advices in this documentation is to install this pg-stat-kcache because it actually really helps with performance. Then you need to modify your Postgres config file. Then create extensions which PGProfile will use for its work. Oops, something went wrong. Sorry. Okay. I'll do it like this. Then install Debian package that you created and create extension. That's actually it. All you need is to add sampling job to which will take actual samples to your cron, like every 30 minutes. This works fine for me. This is what actually library author recommends in documentation, so as simple as this. The other valuable advice from the, I think, middle of this documentation file is to do this It calculates relations between your tables, and when it does it, it uses exclusive access lock, which actually locks your table, and if you if this job runs when your server is actually executes lots of SQL statements, it will actually slow you down, because this access exclusive lock is quite, because it's local all the tables, it will stop your inserts, your updates, and so on. So I put it to some nightly time when we in BestDoctor have very low customers, because our customers are mostly from Moscow, St. Petersburg, most of them. So. And then all you need to do is create report. You can create report by executing SQL like this. Here I take 1 week from now and pass this report to the file, which I can after this download or send to email, and this actually will generate a kind of report that I showed you. So that's it. Very simple. Okay, it will take some work, but it's really simple, and it's very powerful tool. Again, if you are using Postgres and you have some problems with slow queries and performance problems, this tool will greatly help you to, it will simplify your work, because after I installed it, all I had to do is, take this report, open Jira, create some tasks. Okay, I had to actually match these queries with actual Django code to understand who is responsible for these cool effects. But it really simplified my job. So that's it. Your questions?
Thank you very much. It was a great talk. Do we have any questions? We have several. Oh my God, it was interesting stuff, I think.
Yeah, I'm just curious. You tried the tool called the package called Django Sleek, which is itself a nice tool for profiling push requests, which can intercept the queries.
Django Sleek, yeah, we used it, but not on production, because we used it locally, but the problem is, first of all, locally you don't have the amount of data you have on production, because simple example, I think maybe many of you met this in real life. In Django admin, there is some kind of control which takes max min dates to do some fancy filtering. And when you have, little amount of data, it works like a charm. Fast, great tool. When you have like 1 million or more rows in your database, it starts to work very, very slow, because this select max min on a big amount of data is really slow, but you cannot see it on your local machine. So all these local tools are great for some cases, but and again this tool is great for load testing, because when you have load testing, you can generate reports. You know what time you did your load testing. You can generate report for this exact period of time, and again, see only queries that were generated there.
Thank you.
Hi, can you hear me? First of all, thanks for such a nice talk. We actually faced similar problem on one of my projects before, and I'm wondering if you use some sort of tools like Datadog APM to do exactly the same thing.
What the name of the tool again?
So, in my company, we are using Datadog.
Yeah.
Similar
Yeah.
functionality for those spaces.
We used New Relic. I think that Datadog is quite similar. I actually haven't used Datadog myself, but I think they are something of the same. I don't know about Datadog, I can't talk about it, but New Relic was quite useful for profiling Python side of code, but when it comes to SQL queries, New Relic is not very helpful, let's say like this. Yeah. So this one is a tool only for profiling, not profiling, but collecting your queries on your Postgres, but it does the job great.
Okay, any other questions?
Yeah, thank you. One question. I didn't understand why did you choose this tool over PGBudger, because PGBudger is using the log to analyze over that, and this is running queries against running database, I think, extra overhead, right?
Yeah.
And why did you choose this?
Yeah, again, PGBudger uses slow query log. So slow query log, when you, okay, this tool, first of all, this tool catches all your queries, not only slow queries.
You can configure it.
Yeah, you can configure it, but if you do, if your Postgres is quite loaded and you turn on this slow log for all the queries, it will slow your server down completely. We tried that. It just doesn't work at least for us. So again, when you are using PGBudger, you need to collect log. You need to somehow collect it from Postgres server every day, store it somewhere, process it via this PGBudger. It's lots of work, and actually PGBudger doesn't collect these statistics about CPU usage. It's I don't understand why you will want to use Slowlog and PGBudger when you have these tools. It adds very small overhead, really small.
Do you have any numbers?
I don't have any numbers because we couldn't measure it. We added this this extension, and we couldn't see any any overheads more than usual. So I think there must be some, but again, like, okay, let's say 5%. It's nothing. And after we installed this thing, we started to optimize our queries, and yeah.
Okay, thanks. Any other questions?